Hello, my name is Kyle Paul, and welcome to Between the Brackets. This month, our show is on open source development security. So everybody's talking about supply chain software and security. So we have two experts from Google who'll be talking to us and expelling the different myths to where we can uncover what's truly happening with security and open source development. So I would like to invite Anne and Dan, who work at Google on the open source team, to chat with us a little bit more about all things open source security. We're going to talk about supply chain, dependency issues, different vulnerabilities. So a lot of exciting, fun topics that we'll weave in and out of. So, and yeah, welcome, Anne and Dan. Awesome. Cool.
Hello.
Thank you for joining us.
Hey, thanks for having us.
Awesome. Go ahead and give us a quick background on yourselves, who you are, your role at Google, and what excites you about open source.
Yeah, well, I'm Anne. I work in Google's open source programs office, where I'm a security program manager. And a lot of my work is helping Googlers understand, Google releases a lot of open source software, what they should do with regards to security, sharing those practices across open source communities. A lot of our work in the open source office is bringing Google's resources to the wider open source community. And so I do that from a security angle.
Awesome.
Yeah, and I'm Dan. I work with Anne. I'm an engineering lead on our open source security team. So as Anne mentioned, Google produces a ton of open source software. We also use a ton of open source software. And my team's role is to make sure that our supply chain in both directions is as secure as it can be, and we can continue to use and contribute to open source software confidently and securely.
Perfect. Awesome. And thank you to all of our viewers for tuning in. Continue to share this out. If you know others that are interested in open source security, have them tune in. You are also able to ask your questions. This is a live show. So if you have any questions about open source security, make sure to drop them in the live chat and we'll get them answered for you. So first off, thank you for the introductions. And let's go ahead and dive into, let's talk about open source security with supply chain. What is supply chain dependencies? Give us a little background on that.
Sure, I'll start with this one. Yeah, your supply chain is just like outside of software. Your software supply chain is all the steps that are taken for all the different pieces of software, from the time a developer writes them on their keyboard, all the way up to all the different package managers, repackage managers, distributions, all the way up until the time they finally get installed and running in your environment. It's kind of bidirectional too, because as users of software, we're also producers of software, and our software forms a link in the supply chain for all of our customers too. So it's this big chain. That's where the word comes from. It's a chain. It's a graph of all the code that everybody's written ever, going back to the history of time, from the first compilers all the way out to all the software we're writing today. So supply chains are huge and complicated things, and there's tons of places where stuff can go wrong. We're starting to see this happen more and more. If you've been following the news at all lately, people are starting to realize this is a problem, and we're finally taking it seriously and doing a bunch of great work to help improve supply chains for everyone.
And I think it's not only, part of it is that people are starting to take it more seriously, yay. But I think, there's a proliferation in the sharing of software, which from an open source perspective, that's great. That's kind of the whole ethos of sharing, reusing. And I think particularly as we've kind of moved into this containers, cloud native, and DevOps stuff, that proliferation of reusing, resharing is more and more. So that increases the supply chain, which is good and can be negative as well, like Dan was saying.
Interesting. So there are a few recent things that we've kind of talked about where there's different security vulnerabilities that have been uncovered. Can you explore or expand on that a little bit, so that way maybe we can understand what that is, or a more recent reference to that?
Sure. I want to say first, I love that we're doing this one live. I've done a bunch of kind of pre-recorded talks like this, and there have been so many things happening lately that by the time my pre-recorded talk airs, there have been a whole bunch of new recent ones. And so it sounds like I'm talking about stuff in the past. So it's pretty cool we can do this one live. Hopefully there's not a whole new set that are happening while we're in here.
Fingers crossed.
Which one should we start with, Anne? Where do you want to go?
Well, I think we should talk about SolarWinds a little bit and clarify. I think there's kind of some misconception about it's getting mixed up with concerns around open source security, but I think it's a good example of a supply chain attack, because that's really, let's start there, Dan. And then we can move on to the open source ones.
Sure. Yeah, SolarWinds is probably the biggest one. If you've been paying attention to news at all lately, you probably heard about it, this supply chain attack. SolarWinds is a private company. They ship private software for a profit, which is a great way to be a software company. They use open source, but it had nothing to do with this exact attack. So there is some confusion here. There's also, for every supply chain attack, like I talked about before, we're in this complicated graph. There's always two angles to consider, and a lot of times there's some misconceptions there. There's the first angle, which is how somebody, an attacker, sometimes a researcher, which is great when people find these without bad intentions. When they find, when they start the initial attack, how they compromise their first way into this supply chain. Then after that, the real risk, because it's a supply chain attack, is kind of what you pivot to from that first one. So in this case, it was a normal, not a supply chain attack, just a normal attack on infrastructure, which happens all the time. But since SolarWinds is a software manufacturer and distributor, the attackers pivoted and inserted some bad code into some products and kind of waited for it to get distributed that way. The reason this gets compared to open source a lot is because that same thing has been happening in open source. All these repositories on GitHub are big attack points. There's a lot of interest in trying to slip things into them in any way people can, and then wait for it to spread. It's like those kind of the old prison and crime movies where the gates and fences and bars are all strong, so somebody always sneaks in on like a food delivery truck. It's a good way to think about it.
That is a great metaphor, and I'm trying to extend that to one of the common issues we're seeing in open source supply chain compromises is packages and projects that either a maintainer isn't able to maintain anymore, or in another way that an account is taken over. Like if the caterer goes on unemployment and then somebody takes their job, I'm trying to extend your metaphor, Dan. It's not working. Let's drop that. But open source, there's a sustainability problem because it's a lot. It's a lot to put on one person, and then in our dependency chain that's growing and growing, and it just takes one person who's kind of like, I'm not able to maintain this anymore. Someone comes in either, intentionally, maliciously, or unknowingly, and inserts something, and then it dominoes down the whole chain.
I have one pop culture reference that popped into my mind. If any of you are fans of the show Torchwood, there's an episode, Torchwood, it's a spinoff of Doctor Who. And basically there's this one episode where they have a meat delivery company and they're using a vehicle to deliver meat to the local shops. Well, there's this nefarious group that starts using the same delivery trucks to deliver alien meat. And so it's kind of, I guess that would kind of fall into your, they're using the same tool, the same delivery process as a way to inject, nefarious things into the code base.
That's a supply chain attack right there.
So awesome, cool. So so as you were explaining with SolarWinds, they were just kind of where the large point of the attack happened and how their customers were affected by it. So with with that distribution, so you were starting to refer to it's not necessarily an open source thing. Can you expand on that a little bit more, like where open source fits into that attack particularly?
Yeah, well, I think that's one of the confusing things in what you're probably seeing in kind of the tech press about this is it involved proprietary software, but it ended up being a supply chain attack. And supply chain is really on the mind of open source maintainers and users right now. And so I think that's where those messages are getting a little confused. So we're talking about, in both cases, we're talking about compromise through the supply chain, but in the SolarWinds case, it was proprietary software, but that's a really top of mind concern in open source software as well.
Gotcha. We do have a couple questions in the chat that are great ones. The first one from Benson is, in supply chain management, what step, in your opinion, is most vulnerable to attack?
Ooh, Benson, this is a really good question because there's so many steps. What do you think, Dan?
Yeah, this is a great one. Maybe I'll dodge it a little bit by kind of making it a little bit meta. And this kind of ties into what Dan was just saying about open source before too, and where some of the misconceptions are. I think it's really not, apologies for copying out a bit here. It's really not the steps that are the most vulnerable pieces. It's the spots between the steps, I would say. So all the transition points. And the reason this gets so complicated is because we have internal supply chains, right? You might have a team at your company building something, handing it off to another team at your company. But in these big networks, we're taking stuff from different open source projects, different companies, different teams at different companies, and combining them all. So I'd say the most vulnerable step here when you draw this all out is anytime something kind of switches hands between different entities and organizations and different open source projects. Those are the easiest points. And that's why even for closed source software, open source is going to play a huge role in helping secure this. This isn't something any company can solve by themselves, because fundamentally the problem is the linkages between companies and the linkages between projects and everything. So we have to solve this together. We have to build tools that we can use between companies, between countries, to help secure all of this software. And you can't do that internally. You can't do that privately. It's almost tautological. We have to do this together.
Definitely.
One thing I'd add is, in security, when we look at vulnerabilities, there's kind of, when we're scoring them. So if you're familiar with CVSS scores, it's kind of, you get a vulnerability in, you see that CVE, it probably has something called a CVSS score, which is 1 through 10 of its score. But there's many things that go into that. And part of that, we differentiate between exploitability and severity. And so you think about exploitability is kind of like, well, how easy is it for someone to do that? And severity is thinking more about what's the impact when somebody does that. And so if we look at your question, Benson, I think one of the easiest things to help with that supply chain is actually two-factor auth on things like GitHub. That's one of the many, many, many steps in the supply chain, but it's so easy. You just security key. I think they just enabled security keys, if I remember correctly, on GitHub. You can use other things like multi-factor apps for doing that. But that's, in terms of exploitability, so easy. Stop that surface right there. So that's an easy one.
Awesome. Great suggestions there. We do have another question from Jonathan. And he asks, have we noticed a trend of companies creating secure software supply chain teams? They started one at Shopify a couple years ago and have found it to be fruitful.
I don't know if I know trends of other companies, but bravo Shopify for doing that. And I think I'd like to see that. That would be great because, particularly I think you see conversations around DevOps, and then people are talking about DevSecOps, inserting security in there. I think that the next evolution is probably that DevSecOps team thinking about things in terms of their build chains and thinking about how do we secure that start to finish, end to end. So if you have suggestions, Jonathan, from things that were helpful at Shopify or references, please share them because I'd love to see more teams thinking about that.
Yeah, I haven't noticed it yet. I would love to notice, and I predict we're going to start noticing it. Yeah, it's great news to hear that Shopify started that. I think kind of traditionally, this has always fallen into the role of, like Ann said, the DevOps team, the group responsible for deploying and building and operating, wherever those build machines are. And unfortunately, traditionally, it hasn't really been taken as seriously, and there hasn't been as much security concerns here. I think everybody's probably familiar with setting up Jenkins on a little desktop machine running under somebody's desk to do the builds for the whole team. That's how people did it. That's what you had to do, and I'm guilty of that myself in a few cases. And so it's really a shift in culture and starting to take the build machines, the deployment pipelines seriously and treat them like real production software, because they are real production software. It's the doorway into your production environment. So yeah, it's awesome to hear that companies are actually starting to name this and hire real teams for it.
Yeah, that's very exciting to hear, and potentially a future episode. So, locking that one away. We mentioned that there are a few other recent examples. So SolarWinds just happened to be a big one, a major one that was in the news. I know another recent one in the news that came across, my news feed was about the one with, I believe it was the University of Minnesota, that they purposefully injected some bad code into an open source repository?
Yeah, so this was my understanding of the situation is it was a research group or some, I believe they were PhD candidates doing some research. And what they were looking at is the exploitability of that, how code gets merged into open source projects. And in particular, they're looking at the Linux kernel, which has a pretty unique process amongst open source projects. They do a lot of things by email, and there's a very high level of trust there as well. And so this research group was looking at the kernel in particular and looking at, can they exploit that trust chain? And I think where you saw people getting a little upset is open source is really about people, and it's about humans. And a lot of it does come back to trust between individuals. And, unfortunately, people are exploitable. There's social engineering, there's breaking that trust on a human to human level. And so that's what was shown in their project, but I think that's also what you probably saw people getting pretty upset over.
Yeah, that definitely hit the upset part. Definitely crowded the news feed a little bit more. But yeah, that's a great viewpoint in the purpose of the attack and research, and where does research fit in that? When you're trying to do that vulnerability testing, should they have been more upfront about that?
I think maybe part of the challenge is that if you tell people you're going to be sneaking up on them and doing things, then it kind of it ruins it a bit. I think there's a bigger theme here too, which is that like open source is awesome. It's open. Anybody on the internet can contribute. That's the whole model. At the same time, anybody that's been on the internet for longer than 15 minutes probably knows that not everyone on the internet is nice. And so it shouldn't be too big of a surprise to people that when you have something open to the entire world, you're going to get bad actors, whether they're trying to be super malicious and do security things or just abuse and things in general. That's why we also have a code of conducts and stuff like this in all of our projects. So yeah, the Linux kernel, actually, another misconception here is that the Linux kernel team actually did detect all of these bugs coming in, and their code review process did work. But it is people, like Anne said, and people aren't perfect, and we can't expect that. So nothing here really should be too much of a surprise. People make mistakes, people are bad, people do bad things on the internet, and we're relying on people to catch them and fix these things.
Yeah, and I think, a lot of the frustration over it was that open source maintainers this is their time and they're doing their best. And it's a really exhausting and sometimes thankless job. Not everybody, actually very few people are paid to work completely upstream, what we refer to like just on the open source part of the code full time. And that's very rare. And so for a lot of people, they're doing things, 40% of my time or even my personal time after hours is spent working on this. So when people kind of abuse that time and abuse that volunteer time, that's when it can get pretty frustrating for maintainers.
Definitely. Yeah, and that's kind of what, the goal of, why we're bringing both of you on here is to help dispel some of these myths around these major stories that have hit, what is truly happening, and how does the open source community really work together and stuff like that. So thank you for your insights into that. Still continue to ask questions there in the chat. We're gonna go ahead and what are some, we did kind of touch on, like, in the supply chain, we kind of talked about vulnerabilities a little bit. Let's talk about what is the general theme with open source security. What are major concerns with open source security that we kind of should monitor closely?
Sure. Yeah, I'll start on this one. Open source security is an even bigger topic than supply chain, but it gets lumped in a lot because open source is in everyone's supply chain. No matter who you are, you've got some open source in there somewhere in one of your dependencies of your dependencies. So yeah, open source security and open source supply chain security are very similar. Open source security in general, I like to say there's two problems with it. One is that it's open and it's open source. And like I said before, it's open, it's great. That's how people contribute, but not everyone is nice and we don't know who everyone is. And so we've got to be extra careful there in making sure that bad actors are detected, we're reviewing things and we're locking things down, that kind of thing. The other kind of different aspect to it, which is still supply chain, but in a different way, is just that open source software is still software, and all software has bugs, no matter what. There's a lot of kind of misconceptions or something that if you just grab a popular GitHub repo or a popular package on NPM and start using it, it's been up there. It's got 1 million stars. It's got all these great people contributing to it. It must not have any bugs. We can use this in our environment. And yeah, I'm sorry to break the news to you, but there are bugs in there, I promise. All the code I write has bugs. All the code everyone writes has bugs, and sometimes those bugs can be exploited and cause security incidents. And so that's a whole different set of supply chain problems with a different set of solutions. And in the open, a lot of these solutions get harder when you talk about vulnerability disclosures in a public email list and open communities across countries and companies. And it's done a whole bunch of work here to try to help make this easier for maintainers. Yeah, do you want to talk about that?
Yeah, I do. I love talking about vulnerability disclosure stuff. Yeah, because that's one of the big problems. If we'd say there's supply chain issues, there's dependency issues, trust issues. The other thing is getting and sharing vulnerability information, and it's a different kind of two-way stream. But you want to be able to understand what vulnerabilities you are in the projects you're using, and also if you're a project maintainer and you receive a security report from a researcher or a user or anyone, you want to be able to figure out, how do I take that in, assess it, patch it, evaluate it, and then share it with users, get that information out there. And that's gets into kind of incident management, vulnerability management, which is a whole area. And so what we've been doing at Google, actually, kind of getting back to that, how open source maintainers don't have a lot of time and it's a thankless job. So we published this big guide on what's called coordinated vulnerability disclosure, which is when the researcher and the project team are going to work together to figure out how we privately patch this, update it, and then share that information very publicly. And so if it's, let me make sure I get this right, github.com/Google/OSS-vulnerability-guide. There's a whole guide there. There's runbooks, there's templates, and our hope is that that makes things easier for any project maintainer. Because if you are a GitHub user in particular, you'll see that security tab. And if you go click on it, it may say on your project, this project has no security policy. And that is the place that if a security researcher finds something in your project and says, hey, I want to tell you about this so you can get it fixed, that's probably where they're going to go look. And so if you head over to that GitHub repo, we've got everything you need to know to fill that tab, get that information there. And then if you do receive a report, tell you how to handle it, take a breath, it's okay. You're going to figure this out and get it out so users can understand what's in what they're consuming.
Awesome. Can you give us that link one more time so we can drop it in the chat?
Yeah, let me make sure I get it right.
Yeah.
So test this for, I believe it's github.com/Google/OSS-vulnerability-guide. Give that a test first, but I'm like,
cool. Yeah, so we'll test out the link and we'll drop the correct one, that one or the correct one in the chat. So thank you so much for sharing that guide, because yeah, having those guides. So a lot of us software engineers, when we're building our when we're trying to open source a library or open source a project, we don't necessarily have those tools to know what should go into this. And so that's great that Google has put this out there for everyone.
Yeah, and I think it's important too to emphasize that it can feel really scary being like, I'm a project maintainer and I'm suddenly responsible for all this vulnerability handling. I'm not a security person. What am I supposed to do? I really like to emphasize to people, a lot of vulnerability management is not about you being a security person. It's actually about organization and communication. So it's kind of, it sort of in some ways is similar to SRE type things of, it's about, process following and having a plan before you need a plan, a lot of that. So you can do it is my message.
Yeah, that's the last sentence you said there really struck home. Like on these projects, a lot of maintainers just put code on the internet. They didn't sign up to be somebody's incident responder. And what happens if you didn't think about this, you didn't plan before you plan, is that now you're trying to come up with this plan during an emergency when there is a huge bug that you're trying to fix at the same time for people. So just having something written down that you can follow takes so much of the cognitive burden off and helps relieve a lot of the pressure when you're under the pressure, which is the worst time to have to figure out a plan.
Awesome. And since I haven't had a chance to check this guide out, does this also cover like what you should do in the event you do have like disclosure? Or does it cover disclosure, different things like that? Okay.
So it takes you through kind of the whole stage from I got an email or an issue or a Twitter DM, or someone has told me about the intake. Someone's told me about an issue in my project, all the way through to how are we going to work with the reporter to patch it? How are we going to, for some projects, they get into what's called embargo notification, which is a whole thing that I would caution folks to really read about, make sure you're making a informed decision if that's right for you. And then disclosure, which is getting out that security advisory, getting things like a CVE assigned, how we share that information, getting it nice and broadcast to the whole world. So yeah, I'll take you all the way through the process.
Awesome. Very cool. We do have a couple questions. We have another one from our friend Benson, who sent, back to when we referenced social engineering, it's a big liability. How do you solve this challenge in an open source development?
Yeah. The interesting thing here is I think in some ways open source is well positioned to maybe solve this problem because, or not solve, we're never going to solve it, but address, mitigate, remediate. Because so much of communities, they establish cultures and cultures of trust. So, I think you'll find a lot of projects have this core team where they know each other or they've met each other, and over the years they really kind of establish this rapport with each other. And I think that makes a group hardened to, if something kind of seems funky from the outside, like we've got this patch or we've got this person who wants to be a new maintainer and something here doesn't add up to me, I think it gives them kind of group spidey senses, if that makes sense, where you also have continuity. If people are jumping jobs and switching jobs in companies, each company has a different culture. Open source projects maintain that culture long term, regardless of where people are working.
Yeah, I think social engineering is a particularly scary one here. The reassuring part, though, is we aren't actually seeing these attacks too much. They're just like the big scary one that we know we should be worrying about. There's so many other easier attacks, I think, which is why we're not seeing these yet. There are bugs in all sorts of software. The C programming language, which is used for tons of critical infrastructure, is coming up on 50 years old now, and we've got tons of tooling to take away entire classes of bugs that we need to start using. But you can go to any giant C code base and find tons of security issues constantly, and we can find these faster than we can fix them. So there's a bunch of work we have to do, I think, before social engineering becomes the primary way people are getting in. It is pretty scary, though. I think we'll be able to come together and figure it out. It's not just the malicious maintainers like Anne was talking about. There are tons of other social engineering attacks that can happen too, like typo squatting and all sorts of things where people publish packages with fake names and try to trick people into installing them by piggybacking off of packages with real names. There's a whole bunch of different social engineering types of attacks that we're going to have to figure out.
But I think there's a reality to what a malicious security actor, who they are and their motivations, that I'm going to blame Hollywood for getting everybody scared about this. There's no reason an attacker will do the hard thing when the easy thing is available. Like, I think you see these movies and they're like, oh, I'm going to do this thing and break the mainframe, or like, and then like some HTML code scrolls by on the scene and you're like, oh, there's your style sheet. Like, Hollywood does a terrible job of depicting security issues. But I think it does give us a sense that there's some motivation to do this really complicated multi-step attack when the front door was left open. And so I think I would focus, your energies on those things that are the low exploitability, or excuse me, high exploitability, hardening those first, because don't get worried about the multi-step, very complicated thing. Attackers won't do the hard thing when the easy thing is available.
Which is what you were referring to earlier in the episode when we were talking about the two-factor authentication, the multi-factor authentication, and all those different forms of just securing from the get-go.
Exactly.
So.
Yeah, and I think that actually ties back into why supply chain attacks are finally becoming a thing. This one took me a long time to wrap my head around. We've known about them forever. Ken Thompson wrote this awesome paper, if you've never read, in the 80s. I don't remember the exact year, called Reflections on Trusting Trust. And it's terrifying if you read this. And he terrified all of his colleagues when he wrote it. But he did this kind of crazy, intricate supply chain attack that proved, unless you have built every single line of software you've ever used, going back to like the very first part of your compiler. I'm simplifying it a ton, but you can't really trust any of the software you're using. If somebody backdoored something in the 80s like he did, that backdoor can kind of self-propagate everywhere and hide itself, and it could be in every system today. So everybody got scared, and then nobody really paid attention again until the last couple of years, and it's because there were so many other easier doors open. We finally have TLS certificates everywhere because of projects like Let's Encrypt. We're not sending our passwords over plain text to log into websites, hopefully. People are using two-factor authentication instead of their middle names or backwards as their passwords. So these supply chain attacks, it's like the prison metaphor from before. The fences are finally strong enough that sneaking in from the mail truck or the food truck is becoming one of the more attractive ways.
Since we like referencing the past in pop culture, like the movies from the 90s, Hackers, where there's like 3-letter passwords that people were using to secure mainframes, and we're finally past that stage. We do have another comment here from Natalia. Is there any place where we can subscribe to stay up to date on these different security trends, new vulnerabilities, where we can know about this?
That is a great question. I think this is kind of one of the challenges of open source being so kind of a distributed system in a sense, is that each project has its own place that it's going to be publishing its vulnerabilities and kind of new information. But there is an emerging group, and actually Dan is a huge part of this, so I'll let him talk about it. The Open Source Security Open Source Security Foundation. There we go. I have to spell that. OpenSSF. And yeah, Dan, take it away, because you're a big part of this.
Sure. Yeah. The OpenSSF is the link is openssf.org if you want to put that one up here too. Cool. It's a group of a bunch of companies and open source projects that have come together to start to get a lot of these things in one place. If you're looking for trends and best practices and things like that, then this group is for you. New vulnerabilities is a little bit different. That's a scarier one. There's that ties back into Anne's whole disclosure policy thing. The best place to track those is the whatever vulnerability disclosure process your projects are following, and common feeds like the CVE feed and the NIST trackers that way. So what other places can people find new security vulnerabilities that might be affecting them? I think that's a bit different.
Yeah, and there's actually a lot of tooling around that. Both, I think there's some open source and software companies, vendors that do this as well. You can either be subscribed to every project you use and every dependency's security announcements, and when they have a new CVE and they release it, that's where they get it. That's not really scalable. That's not feasible, particularly when we talk about all those dependencies. So there's a lot of tools that will scan for metadata and see, has this been updated, and it says there's a new CVE, you're affected, here's your daily email of all the things you might want to go patch or something like that. So trying to think of software composition analysis is an easy search term, as probably you'll find a lot of tooling around that.
Awesome, cool, thank you. Yeah, we're happy to stay on top of all of this, because as Natalia mentioned, I love cyber, so so yeah, we have a lot of great people on the chat right now talking about different security issues that they're passionate about. We do have another one from Robert, who is asking about public backend code for decentralized apps is an industry standard. Any opinions on how forking app code might result in security concerns, which differs from Web 2.0 open source code?
I want to make sure I'm understanding the question you're getting at correctly. But basically, it's asking, in open source, there's a thing called forking, which is allowed by licenses. And that's one of the beautiful things about it, is a different group wants to say, I want to do things differently. Particularly common licenses you see like Apache 2 allow this, that I can take it, I can modify it. Here's my fork. Asking about if a branch goes off and does its own thing and there's a security issue in the original branch, how does the second one know about it? And I think that's a real concern that gets down to communication between projects, communication between maintainers, those forks understanding what their dependencies are and are not as they build further and further away, and keeping track of those. It kind of, I think our theme of the day is that dependency problem. It can get really quite gnarly.
I would add it, because you pointed out, like, if it's the Apache 2.0 license, you have free to fork and do as you will. There are certain open source licenses which ask you, if you happen to find a dependency or you change or modify something, that you put that back upstream back into the original source as well. So it depends on the licenses.
It does. It does. And I think that's an important thing for open source users in general. Understand what licenses you're using. I know this isn't a security topic, but it's really important. Understand what licenses you're using. There's licenses, what Kyle was referring to, copyleft of, I need to, if I modify it, I'm obligated to give that modification back and all that. So it can get a little complicated. Yeah.
Yeah, I think that question, when I read it again the second time, I think it might have actually been specific to things like blockchain and this new notion of like distributed applications and decentralized applications, where you don't really have a central server. Everyone is trusting. Everyone's kind of running the same code base and enforcing mutual trust and transparency against all of each other. One of the techniques there, like you mentioned, is open sourcing any backend things that do exist, so people can kind of audit those and see, make sure the backend code is running what they think they are. Techniques like reproducible builds and verifiable builds help out there too, to make sure everybody is running the same copy of software. A lot of those security guarantees depend on everybody upgrading kind of in lockstep and running identical pieces, and so there are a bunch of kind of build techniques that can help out with those. I'm not a super expert in that area, though. I know it's getting really popular today, though.
Awesome. Robert responded in the chat. Great answers. So thank you. That seemed to answer the question there. Awesome. Cool. We have another one from Chaba. Hopefully I'm saying your name correctly. What's your opinion about the Linux kernel versus UMN kernel development process? Oh, we did kind of touch on this a little bit earlier, but
that's paper shenanigan. I love that.
Yeah.
Yeah. So I think this is a very, I'll run with the fact that you referred to this as a pen test known as a penetration test. So a very important part of that is consent, essentially. That usually what happens if I'm, be it proprietary or open source, you might say, hey, I want to actually find out where my security holes are and where my gaps, and I want to harden this project. A really good way to do that is to get a penetration test. And like our Hollywood movies that we were referring back to, if you've seen Sneakers or Hackers, you'll see these be plot lines in there. Someone will come in and try to figure out, how can I exploit this project? How can I find some weaknesses? How can I do something that maybe the team, when they were hardening it or thinking about their security design in the beginning, didn't think of? It's a really good way to find gaps. But there's a consent model there where someone has asked someone else to do that. And I think part of the issue is that everyone knows that trust is a really big part of open source, and no one asked for this to happen to the kernel's process. So, yeah. But I will say, for open source projects, if you have the funding and ability, and you're ready for it, I think a penetration test is only good if when you receive all those results, you have the resources to implement the suggestions and go do the hardening. And so there are some open source projects that have had audits and pen tests like that. And I believe Kubernetes is one, for an example. I think they've got some really good results and found quite a few things that they could harden, which was great.
Yeah, and on that same topic, Kubernetes actually, they started a bug bounty program in addition to their audit, where people can report, researchers are encouraged to report findings responsibly to the project. One of my favorite parts of the Kubernetes bug bounty program is that it includes supply chain attacks like this. So they have explicit guidelines for ways people can engage and poke at the Kubernetes supply chain and report things that the release engineering group and the maintainers can fix, and that includes the ways that they want to be researched. And the ways that they don't. So it's great that people are aware of these types of things and are publishing guidelines around it. I expect we'll see a lot more projects start explicitly including supply chain attacks in their bug bounty programs in the future.
I will add, though, don't sign your project up for a bug bounty if you do not have a disclosure program and a process and kind of a mature system. Bug bounties are like turning on the fire hose of vulnerability reports. And if you're ready for that, they can be a really useful tool. If you are not ready, they're going to be a disaster. So security maturity roadmap, get your vulnerability disclosure programs up and running, understand how to do that, and then turn the fire hose on.
Great caveat there. Yes. So, since you bring up the bug bounty program, is that a good way as an engineer to see how to secure my own library? Is it just to kind of follow these bug bounties or participate in these bug bounties? Is that something that you would recommend?
Signing up your program or hunting after the cache yourself?
Yeah, hunting down yourself, or just staying in tune with what's happening with the disclosures and like what if let's say your library that you're building that's open source is very tangent but related, you might be using the same language, same framework, something like that, and you want to follow it more closely. Like, how would you recommend somebody does that?
I have to think about who to pay attention to for following. I know for Google, we have kind of this a bug bounty program, and we'll publish results frequently on the Google security blog, kind of some yearly wrap-ups of here's some really interesting things we saw. And I think reading those could inspire folks of, oh, I have a similar architecture, or I do use this language or this project. I might actually be vulnerable to this or vulnerable to a kind of modification of this. That could be really interesting. Bug bounties, if people have the time and want to sign up and poke around things and see what you find, you might earn some cash. You might not. We should be frank about, I think in all these programs, they'll be pretty clear about what's in scope and what the payout looks like, so that you can set your expectations accordingly. But yeah, if you're a project maintainer, I wouldn't sign up your project for bounty until you really understand what you're going to do with that information, and if you're prepared to handle reports. There can be some good cash if you find something good. There's money.
Definitely.
There's a second half of that too that I want to plug. Your work doesn't stop, or the maintainer's work doesn't stop, and your work doesn't stop when you find a bug. Somebody has to go and fix it. And we're also trying a bunch of models to help encourage the opposite side there of patch rewards and patch bounties. So for projects that do have issues, bugs that have been reported and nobody's around to fix, Google runs a patch reward program. And I can't even guess the link in the top of my head right now. I'm blanking, but if somebody can find it by searching, it'd be good to add here. But if you're interested in more than just finding bugs, actually fixing them, there's a long list of projects with known bugs that are just waiting for someone to fix, and you can make a bunch of cash that way too. So don't think your job is over just because you found a bug. Somebody has to go and fix it.
Definitely. And you both touched on where I was trying to lead to. So the patch bounty program and the Google security blog. So great. So with that too, this is kind of a way, the bug fixing thing. There is Hacktober, which is a tag that shows up on GitHub in around October. And so if you're new to coding, or you want to help solve some of these bugs that are out there, that's a great way to kind of get started on contributing to different open source projects. Do you, Anne or Dan, do you have any other tags that they should be looking for, or repos that you know of?
Yeah, so I believe a lot of the Hacktober issues get marked good first issue, and that's a common thing to see in GitHub projects. And you can access that all year long. It's what now, May? You don't have to wait till October. You can find good first issue, and a lot of projects will have their kind of contributor guides somewhere in their repository, so you can figure out, okay, how does this project work? How should I tackle this? And those are great places to get started. I'll also plug, there's some programs we run at Google, like Google Summer of Code. And what happens there is open source projects kind of get some grants to go work on specific issues. And then those projects are sometimes looking for additional help to get students in the door, get first timers to open source in the door. So you can kind of learn more a little bit at that at opensource.google. Under the community tab, you'll see Google Summer of Code there. You can check that out. Dan, any other things that come to mind for you?
I would just add, most open source projects are welcoming. They really want to encourage new contributors. The biggest rule of advice when you're starting something like this, just make sure you're being respectful of the maintainer's time. That's kind of the recurring theme. Hacktoberfest last year kind of unintentionally turned into like a denial, like a DDoS or denial of service attack on a lot of open source projects, there was way more demand for these free t-shirts. It's just like in college days, people do anything for a free t-shirt. There's way more demand to get these free t-shirts than people expected, and people are showing up and sending lots of tiny pull requests just to get the t-shirts, and it ended up overwhelming a lot of projects and maintainers. So I think there was a lot of lessons got learned there too. How much people want t-shirts, and also how much time this does take for maintainers. So yeah, as you approach projects, that's kind of the number one rule of advice I would have, is just be respectful of everyone's time. But
Definitely
people are
points.
always welcoming and to help out when you are as well.
Definitely good points all around. We do have another couple more questions in the chat. This one from Benson again. What happens if an organization is unable to solve security gaps? Do you see them closing for the sake of closing the project for the sake of the customers or the users, or what does typically happen if they can't solve those security gaps?
Whoa. So there's a couple ways to pull this question apart, a couple ways you can take it. So let's start with this in the security gap in the case of a vulnerability. So let's say I have something reported to my open source project or even proprietary software, it kind of will follow the same thing. And there's typically an agreed upon disclosure period between the reportee and the reporter or the researcher. And 90 days, for example, is a very frequent one. And so let's say it's day 87 and our patch isn't working right. We just cannot make this fix how we think it should be done. Well, a typical tactic is to try and break the exploit chain. So can I release a partial patch? Can I kind of put a Band-Aid on it to make the exact attack stop? Maybe there's some workarounds that someone could do, but we're going to get out what we can. And a lot of this is coming from the fact that, users can't protect themselves from what they don't know about. And so if we've given our honest effort, we're tried our best, we've got, break the exploit chain. The thing is to keep working on it and keep trying. But then if users are aware, they can at least take steps themselves to mitigate what they're vulnerable to that they didn't know about. In terms of open source projects, this is an interesting area where because of that maintainer burnout and the work that comes with maintaining a project, you find a lot of abandonware essentially open source, but it's not intentional. It's just, I ran this project for 2 years. I'm tired. Nobody else kind of took it over. It was too much work and it was time for me to step away, and no one else stepped in. So I think it's I would like to see a little bit more happening in the open source communities around deprecating and archiving projects. I think it's just a thing to do to make sure users understand no one's here looking at this, don't accidentally use it. That's a security liability there. And I think sometimes we're afraid to close things down and say, flip on that GitHub archive button. It is still forkable to get back to the licenses and the fork. So if somebody wants to come along and say, I really want to pick this back up, it can be picked back up. But I think using that archive tab when nobody's paying attention, it's important so users don't accidentally use something that's quite out of date.
Yeah, just building on that, a lot of the projects with the security apps, there's nobody there to even close it. Again, it's saying people have moved on. Software does go stale over time. Bugs get found because all software has bugs. They get found eventually. And if there's nobody left maintaining the project anymore, the bugs just sit there as known issues. And the project, I wrote a whole blog post about this. I found a bunch of them. I call them like zombie dependencies. They're floating around. You don't know they're deprecated because not every project changes constantly. And the maintainers have just moved on, and you don't know until it's too late and there's a CVE found, and then you've got to go and figure out how to update and move to something else at the last minute, which is challenging. That's the last time you want to be migrating, is when there's a known vulnerability. So it's unfortunate, but it happens.
Definitely. We do have another question from Jonathan. He says, I'm a developer that wrote some software and put it on GitHub. Do you have any suggestions for securing my software that doesn't cost money? What's your favorite OSS security pro tip? There's a few things that have been tossed around to help him in the chat, but I still wanted to bring this question up to both of you.
Dan, there's probably quite a few tools coming out of your team that do not cost any money.
Yeah, there's so much basic stuff, even integrated into GitHub and tons of other free and open source tools as well. Turning on a bunch of the normal protection settings in GitHub, turning on branch protection, turning on two-factor authentication is great for you and your users, so it's not protected just by your password on your laptop. That's kind of just securing actually the where the software is sitting on GitHub as well is really important. And then depending on the language and toolchain and everything like that you're running, there's tons of tools and linkers and scanners to help detect security issues. It's part of the whole like shift left concept, the buzzword that I hate. But finding security issues before you check them in, there's tons of free scanners and tools there, as well as things like Dependabot that'll automatically send you updates for free when one of your vulnerability or one of your packages, your dependency packages has a vulnerability. So you can just kind of click merge. Lots of stuff, and really, I'm sure there's some great answers if there are more specifics in the chat.
Fuzzers.
Yeah.
Yeah, I think there's OSS Fuzz is a Google project that's also on GitHub. It's open source. It's free for projects to use. So you can set up fuzzing for your project that way. And that could be a really good one.
Awesome. Cool. And I know we're getting down in the last final minutes of the episode. I did make note of this because we kind of accidentally skipped over it, but because we did talk about this, kind of relates to Jonathan's question, but we talked about using two-factor. We talked about the MFA. We talked about implementing a security policy. But one of the other cool things that you can do is sign your releases. So do you want to dive into that a little bit?
Yeah, this has come up a lot with a lot of the different supply chain attacks, like the CodeCov one that's happened recently, even SolarWinds. Signing your code is really hard to do today, and if you look across the internet, most people just aren't doing it, especially in open source. But as we start to try to build up integrity and supply chains that we can understand and believe in and secure, code signing is going to be a valuable part of that. So we've been working on a bunch of efforts to try to make this easier across Google, including most exciting ones that I've been a part of is called SigStore. So SIGSTORE.dev, if you want to go there. The idea is to try to make it as easy as possible for open source developers to sign their code for free without having to know all the cryptography details and stuff like that. So trying to do what Let's Encrypt did for TLS across the web, except for code signing and supply chains.
So, and it was sigstore.dev?
Yes, I think.
Yeah, and you said the magic word cryptography, because I was going to say to clarify, it's not signing the way you might see what's called like signing off on an open source commit. This is cryptographic signing of the build. I don't know if you want to say a little bit more about that.
Yeah, good point. Yeah, this is like a digital signature or cryptographic signature that provides some guarantees, not like DocuSign or signing your name with a pen.
Awesome. Cool. So thank you for letting us know about this tool. Everybody in the chat just exploded over that one. Oh. So very cool. And it's great to know about different ways to secure our projects just beyond the different stages where we can do this securing. There is one final topic I wanted to make sure we bring in there is there's always different open source projects that need help with funding. Because as Jonathan mentioned earlier, he's building something that's open source. He doesn't have the funds necessarily to put everything together. What does funding mean for open source, and what are some suggestions that you have?
Yeah, it's hard. And I think one of the lessons we've learned, we've been trying to fund and help open source projects for years here at Google, is that every project needs different help. Some people need equipment, some people need compute time, some people need cloud credits, and some people do need, like everyone needs to get paid for their work. So some people need that too. Sometimes there's an open source project where a person has a full-time job and you can't just pay them to do more work. So they need actual like hands-on keyboard help. They can't just take a check. So it's really challenging, and everybody needs different types of resources to help. So it's an open source project that needs help. I recommend just trying to be as clear as possible about how companies can help you. And as companies, I would recommend just taking a look at your dependency list and seeing which projects you might be using. There's a great XKCD about this that I wish I could make appear here to point to. But yeah, like all modern digital infrastructure is, at the end built on top of one person maintaining software thanklessly that nobody even knows exists. As a company, I would really recommend looking into all the stuff you're using and seeing if people need help and figuring out different ways that your company might be able to help, whether it's funding or dedicated time from maintainers. We found these investments are huge return, or this funding is a huge return on investment for us. It's way easier to work with maintainers that are already familiar with the project and just need a little bit of help than it is to fork something, rewrite it all from scratch, or try to patch around bugs on our own.
And if there's project maintainers listening, I think too, because I've been in this position where you're maintaining something and the burden is getting too much. You're like, I can't do this, I can't do this. And you don't say anything until it's like the explosion of burnout. I think all of our industry, and also for our own well-being, everybody could do a little bit better if saying it earlier, figure out, say this isn't working, this isn't a sustainable workload for this project, before you get to that point of like, we got to shut this thing down or we got to walk away.
Definitely good tips there. We also, we are still closing up on some time. I'm trying to double check the chat if we have any other questions in here. I know we've been dropping a lot of great links, so thank you all for sharing that. Those different projects, initiatives, information on to help our different engineers out there maintaining, using, and understanding security behind open source. I'm just taking a quick scroll. I don't see anything right at the moment, but I want to thank both of you for joining us today. Do want to be mindful of your schedules because we are coming up on the hour. To go ahead and close out, I want to thank everyone for tuning in to this month's episode of Between the Brackets. I want to do a special thank you to Anne and Dan for taking time out of their busy schedules today, and all of you for tuning in because Google I/O is actually happening today too. So thank you for tuning in and joining us on this special episode on open source security. I also want to thank Daniel and Bertucio, who are backstage helping to run the show. You've seen them in the chat and the different transitions that are happening. So I want to thank everyone for tuning in again. Make sure to subscribe to our channel, as well as go to goo.gle/between-the-brackets. We'll have that link up here on the screen in a second. And so, you can register there, go see past episodes to see what all we talk about and all the fun, different topics, that we bring to the community, which it's much different than you'll typically see. You're not going to find these kind of answers in the dev docs. You might not necessarily see blog posts about any of this. So this is where we bring the experts on stage, ask them these challenging, fun questions. So thank you again, Anne and Dan, for joining us.
Thanks for having us.
Awesome. Thanks.
Any parting words for our audience? What about open source security?
You can do it.
Yeah, it's scary, but yeah, we'll figure it out together.
Yeah.
Awesome, cool. Well, thank you both so much. Yes, such a great episode. Perfect. Cool. So thank you all for joining us. Stay tuned for next time.